Okay, let's give you guys some practice. So here, find the derivative of y equals 2x squared plus 3x plus 5. Me asking you to find the derivative of this thing here, it's like me asking you to find the gradient of this thing here. So that's the same as me asking you find dy by dx of this thing here. Okay, so remember, start out by sketching this graph here. So the graph may look something like this. Okay, so select a point A. Remember, set up our system where you have a point A here, and then the point B here, and then say to yourself the gradient that exists between A and B is given by, well, gradient equals f of x plus h, take away f of x divided by h. And then normally, so start out by sketching this graph here, and then set up this system here where you have 2 points A and B. So you say to yourself, the gradient that exists between A and B is given by this thing here. But then the true gradient, so normally we would say true gradient, normally we would say true gradient equals blah blah blah. But we're not going to say true gradient anymore. We're going to say dy by dx equals. Well, first start out by sketching your graph, and then set up this system here, and then say to yourself the gradient that exists between A and B is given by this. But then the true gradient, which is dy by dx, equals is when you start to take the limit as this h here tends to 0. So from here, the gradient that exists between A and B is given by this, and then start to say to yourself, then the true gradient, which is dy by dx, is when you take the limit of as h tends to 0 of this of f of x plus h, take away f of x, and then over h here. Okay, and just try your best then. Find the gradient, find the derivative of this graph here. Okay, so press pause and have a go. Okay, so start out by sketching this graph here, this equation here. So when x is small, it wants to do this thing here. So it wants to have an intercept of 5 and a gradient of 3. So when x is small, it wants to do something like this. Okay, and when x is big, it wants to do this thing here. So it wants to do a quadratic, a positive quadratic. So now join up the 3 parts. So it will look something like this. Okay, so this is our rough sketch, and then set up our 2 points. This point here is A, and then this point here is B, and now you've got to say to yourself the gradient that exists between A and B is given by f of x plus h, take away f of x, and then divided by h. Remember, h is this distance here. Okay, but then the true gradient, which is now we're going to use dy by dx. The true gradient is when you start to take the limit as h tends to 0 of this thing here, f of x, f of x plus h, take away f of x, divided by h. So we are currently here. Okay, so now hang on. So now remember that our original equation was this here. So remember that we're doing this here, f of x plus h, take away f of x, and then over h here, and we're taking the limit as h tends to 0. So remember dy by dx is this here. So now looking at this here, if you put x plus h into here and into here, that will give you this whole oh yeah, and the 5, x plus h plays no part in the constant here, so the 5 remains the same. So hang on, yeah, so this whole thing here will become this, and then you take away. So this takeaway here is right here. Take away this whole bubble here. Okay, so you're taking away the whole bubble here. That's why the brackets exist here. That's why the square brackets here exist. Okay, and then now it's just using algebra. Now it looks complicated, but well, just multiply this bit out. That will then give you this here. Okay, so the 2's on the outside, the 2's on the outside, and then do 3 times x, and then 3 times h here. That will give you these two. The 5, well, the 5 will remain the same. And remember it was us doing this. Hang on, h, take away f of x here. So this takeaway here is on the outside, and this here is the whole thing is in a bubble. So the whole thing here is in a bubble, meaning that you've got to do this here. So this will become minus 2x squared, and then this thing here will become minus 3x, and then it becomes minus 5x. Okay, so now it's just a matter of simplifying. So this times this, which will give you this. This times this, which will give you this. This times this, which will give you this. And then everything else stays the same. So take the whole thing here. Take the whole thing here down. Okay. So now they will start to cancel each other out. So this one and this one, they will cancel out. And then you've got your 3x here minus 3x here. So they will kill each other off. And then you've got the 5 here, the minus 5 here. So all that you're left is this, which is this thing here. 2h squared, that will give you this, and this will be this here. And then now factor out the h. So look, h is in common here, h is in common here, h is in common here. Factor out the h, and then the 2 will cancel out. That will give you this. Now start to take the limit as h tends to 0. Well, h tends to 0 is as h tends to 0, h will be so you will have 2 times 0.0000000. Well, this term here will also tend to 0. Okay, so you will in effect have this. So here dy by dx is exactly this. It's truly this. Okay, so as a summary, we started out with our graph y equals blah blah blah. We roughly sketched it as this, and then and now that we know that dy by dx equals this thing here, we can actually sketch a graph of dy by dx. Okay, so looking at this here, hang on. So this was our original graph here, and then this is our dy by dx. Our dy by dx will look like this. And if you think about it, right at this point here, the gradient is 0. So when you if you were to draw a vertical line down here, well, this value here should match up with this value here. This x here should match up with this x here. So normally I in the past I've taught you how to draw this graph here, and then we spent ages trying to find this location here, this the value of x, where well we had to complete the square in order to find out this point here. We did a lot of work in order to find out this point. Well, you could just find dy by dx of this thing here, which is this bit here, and this where you see at this point here the gradient 0. So well, I will show you this another time. But if you want to find out this point here, you can just look at this here and say, when does this thing equal 0? Because here you can see that the gradient. Don't forget, this is your graph of y equals blah blah blah. Okay, and now this is your gradient graph, and then you can see that at this point here the gradient is 0. So I will show you this another time. Okay, it doesn't matter if you don't understand it. But what I'm trying to say is that once you've got your graph here, you see dy by dx. Once you've got your gradient graph, it really helps you to understand your original graph. But I will show you that another time. Don't worry about it too much. But the answer to the question is this here. And if you want to know the gradient at, let's say at x equals 2 here, then you would jump to your dy by dx and then put 2 into this thing here. Okay, so the gradient, so this point here, when x equals 2 here, this gradient here is, well, put 2 into this thing here. So this bit here will be 8. 8 plus 3 will be 11. So the gradient here will be 11. Okay, but well, your answer here, your dy by dx is given by this. So this is your final answer. Okay.